friends, welcome to Cyber Channel. As I told, we will have a 1 minute challenge today. So what we are going to do today is we are going to derive wheatstone bridge. So what does a wheatstone bridge consist of? A wheatstone bridge consists of 4 arms: AB, BC, CD and AD, right? 3 arms will have known resistance and 1 arm will have unknown resistance which can be found. Okay, so who invented it? That is Charles Wheatstone. And then it consists of 4 arms, and where it is used to find a resistance of milliohms, and it is used in measuring calibration of ammeter and voltmeter. So one assumptions we are going to take: the voltage across the node B and D will be equal, so that the current will not flow through the galvanometer, so Ig becomes 0. That is the only one assumption we are going to take. What are the 2 laws used? 2 laws used are KCL and KVL. KCL is current entering the node is equal to current leaving the node. KVL is algebraic sum of voltage should be equal to 0. Let's start deriving. So this is a typical Wheatstone bridge. Instead of galvanometer, the resistance RT is replaced because galvanometer got its own resistance. So there are 4, let's say R2 is unknown. So this is unknown. I don't know what is this, so that is unknown, right? Okay, so the total current entering the bridge is I, and then it is dividing it as I1 and I2, right? Some part of I1 is going as Ig and the remaining is going as I3. Here, I2 is the current going, and then some part is going in Ig and the remaining is I4, right? So applied voltage, let's say the battery voltage is E. So now we are going to derive. We will start applying KCL first. What is KCL? Current entering the node will be equal to current leaving the node. What is that? We are going to take node B. So this is node B. What is the current entering? Current entering is I1 is equal to current leaving. Current leaving is Ig and I3. So I1 is equal to Ig plus I3. That is my equation number 1. Now I am going to apply KCL at C. So what is the current entering? Current entering is I2. Current entering is also Ig. So what is the current leaving? Leaving current is I4. So that is my equation number 2. So both the equations solved now. So after KCL done, now I am going to apply KVL, right? Listen. What we are going to do is we are going to take loop A, B, C and A. So I'm going to start here. Applied voltage V is equal to IR. Remember that formula. So I1, R1. These are clockwise, so we are going to take it as positive. I1 R1 plus IG RG minus, because this is coming in opposite direction, minus I2 R3 is equal to 0. That is my equation number 3. So again a KVL in the other loop, which is going to be B, D, C, B, right? So this is clockwise, so I am taking it as positive. I3 R2 minus I4 R4. Again, this is going to be minus Ig Rg is equal to 0. That is my equation number 4. If the bridge is balanced, voltage across B and C will be same. So current will not flow through galvanometer. So assuming if galvanometer current is 0, the bridge is balanced. The voltage across B and C will be equal. So which means potential difference between the 2 nodes is 0. So no current will flow through the galvanometer. So if Ig is equal to 0, I am going to substitute in 1, 2, 3 and 4. So if I substitute in 1, what will happen? I1 is equal to, Ig becomes 0. So I1 is equal to I3. So that is 1. So let's say that is equation number 5. Here if I substitute Ig is equal to 0, I get I2 is equal to I4. So that is my equation number 6. Now I am going to substitute Ig is equal to 0 in 3 and 4. Right. If I substitute Ig is equal to 0, what will happen here? So I1, R1, Ig is 0, right? So I am going to leave it minus I2, R3 is equal to 0. So I1, R1 is equal to I2 R3. So which means I1 by I2 is equal to R3 by R1. So let's say that is my equation number 7. Similarly, I am going to substitute here as well. So what here I am going to put Ig is equal to 0. So I3 into R2 minus I4 into R4. This becomes 0. So it becomes I3 R2 is equal to I4 R4, which means I3 by I4 is equal to R4 by R2. We know the values of I3 and I4. What is I3 and I4? I3 is equal to I1, I4 is equal to I2. So instead of I3 I can put I1, instead of I4 I can put I2. So I1 by I2 is equal to R4 by R2. So that is my equation number 8. You can see LHS of equation 7, LHS of equation number 8 are same. So equating both, if LHS are same, we can equate the RHS. So which means R3 by R1 is equal to R4 by R2. What I need is R2. So R2 is equal to, R2 goes the other side, R4 by R1 into R3. So R2 comes this side, R1 goes here and R3 will come here. So R2 is equal to R4 into R1 by R3. We can find the unknown resistance, right? So what are the things I will just quickly summarize. So we use the KCL, apply KCL at B and C. So you find two equations and then apply. One loop is A, B, C, A and other loop is B, D, C, B, right? So apply and then the condition is ID will be equal to 0, substitute in everything and find the unknown resistance. So this is the 1 minute challenge we gave to you. So what you need to do is, you're going to work out, record it and send it to us. We will see who is doing faster. If you like the video, subscribe it and thanks for following us. Thank you.